When students develop formulas rather than just being told the formula, they gain conceptual understanding of the idea and the relationships involved, and they engage in doing mathematics. Begin by having students generate ways that the perimeter problems can be solved. Sometimes problems show just 2 sides, some show 4 sides. So start with the perimeter formula, a length plus a width plus a length plus a width for a rectangle that clarifies that 4 length dimensions can be added. Later on, you can condense the perimeter formula as 2 parentheses L plus W or 2L plus 2W. Confusing linear and square units. A focus on the formula and the use of the ruler to measure the sides confuses the units as well as the tool for measuring the area. This confusion can cause some students to believe that if there are no sides to measure, no length and width, the shape does not exist. Length times width is not a definition of area. Instead, area is the measure of two-dimensional surface enclosed by a boundary. Difficulty in conceptualizing the meaning of the height and the base. In the figures on the side, each have a slanted side and height given. Students tend to confuse these two. Any side of a figure can be called a base. For each base that a figure has, there is corresponding height. If the figures were to slide into a room on a selected base, the height would be the height of the shortest door that it could pass through without tipping on its side. Area of a rectangle. When you multiply length times its width, we are not multiplying square times square. Rather than the length of one side indicates how many squares will fit on that side. If this set of squares is taken as a unit, then the length of the other side will determine how many rows of the square can fit in the rectangle. Then the number of square units covering the rectangle is the product of the length of row and the number of rows. Column times row equals the area. Parallelograms. If students are having a problem, ask them to examine why a parallelogram is like a rectangle, or if it can be changed into a rectangle by decomposing and recomposing the shape, as in the figures below. A parallelogram can always be transformed into a rectangle with the same base and the same height and the same area. Therefore, the formula of an area of a parallelogram is exactly the same as a rectangle, base and height. In the figures, again, 2 congruent triangles can always be arranged to form a parallelogram with the same base and the same height as the triangle. The area of the triangle will therefore be half of the parallelogram, half the base times the height. And the last figure shows the method of results in the formula of a trapezoid. Make a parallelogram inside the given trapezoid using 3 of the sides. Make a parallelogram using 3 of the sides that surround the trapezoid. Draw a diagonal forming 2 triangles. Draw a line through the midpoints of a non-parallel side. The length of the line is the average of the length of 2 parallelograms. You can draw a rectangle inside the trapezoid, leaving 2 triangles, then put them with those 2 triangles together. The relationship between the circumference of a circle and the length of the diameter is one of the most interesting. The circumference of every circle is about 3 14/100 times as long as the diameter. The Greek symbol pi is what we use for pi, 3.14. So pi is equal to circumference divided by diameter. Area of a circle, you can cover the circle with tiles. Place 1-inch square tiles on the circle and cut out the squares that can be glued on. You can use radius squares. You can draw a circle plus a radius. Set the radius as the unit. Use the radius unit to make squares. We will call them radius squares. You can form a grid of 2 by 2 radius squares and draw a circle inside of it. By observation, you can see the circle inscribed in the grid has less than an area of 4 square radius. Cut to make a parallelogram. Cut circles apart into sectors and rearrange them so it looks like a parallelogram. The figure below presents a common development of the area formula. A equals pi r squared. Volume and capacity are terms for measuring the size of a three-dimensional region. The term liquid volume or capacity is generally used to refer to the amount that a container will hold. Standard units of capacity are quarts, gallons, liters, milliliters. The term volume can be used to refer to the capacity of a container. One way to find the capacity is to fill one container with something and then pour it out into a comparison container. To compare volumes of solids, such as a ball and an apple, a displacement method can be used. Have students predict which object has the smaller or greater volume, and then place it in the measuring cup or beaker. A good activities are on page 45, capacity sorts and fixed volume comparison prisms, 1826 and 1827. A cylinder is a solid with two congruent parallel bases and sides that parallel the element that join corresponding points on the bases. There are several special classes of cylinders, including prisms, right prisms, and rectangular prisms. In the figure at the right, the area of a base determines how many cubes can cover the base, forming a special single unit of a layer of cubes. The height of the box can be determined how many layers that fit in the box, just as the height of a rectangle determines how many rows of a square units should be filled. Area is a two-dimensional figure, but volume is a three-dimensional figure. Furthermore, triangles are parallelograms as cones are to cylinders. To investigate this relationship, the use of translucent plastic models and having a student estimates the number of times the volume of a pyramid will fit into a prism. Have students test the prediction by filling a pyramid with water and emptying it into a prism. They will discover that the volume of a three pyramid will precisely fill a prism with the same base and height, making the volume of a pyramid 1/3 the volume of a corresponding cylinder. The most conceptual way to compare heights of two objects is to hold them in one hand, extend your arms, and experience the relative downward pull of each. When students place two objects in the pan of a balance, the pan that goes down can be understood to be the heavier object. Any collection of uniform objects with the same mass can serve as a non-standard unit. That is, for the light objects, larger paper clips, wooden blocks, or plastic cubes or coins. Standard weights are needed to weigh things that are heavier, such as kilograms. To help students conceptualize the attributes of the spread of two rays, two angles can be directly compared by tracing one and placing it over the other, as in the figures below. Be sure to have students compare angles with rays of different lengths. A student may think a wide angle with a short ray is smaller than a normal ray with longer rays, a common misconception among students. A common way to measure angles is with the protractor. It's in the bottom right and it's green. Following suggestions can help students focus on the action of and functions of minutes and hours. Begin with one-handed clocks by bringing off the minute hand from the rectangle or regular clock. Use lots of appropriate languages. It's about 7 o'clock, it's about 9 o'clock, it's halfway between 2 o'clock and 3 o'clock. 2. Discuss what happens to the big hand with the little hand goes from 1 hour to the next hour. 3. Use two clocks, one with an hour hand, the other with two hands. Cover the two-handed clock periodically during the day. Direct attention to one-handed clock. Have students predict where the minutes on the clock should be. Use two clocks, one with an hour hand and one with two hands. Cover the two-handed clock periodically during the day. After this set 3 has begun, teach 5-minute intervals by counting 5 going around the clock. Instead of saying minute hand is pointing at the 4, transition students to precise languages. Predict the reading of a digital clock when shown on an angle clock and set along the analog clock. Relate to the time after the hour to the time before the hour. Students must be able to tell how many minutes to the next hour. Figuring the time from 8:15 to 11:45 is a multi-step task that requires decisions what to do first in keeping track of the international dateline steps. In this case, you could count from 8:15 to 11:15 and add 30 minutes. But then what do students do if the endpoints are 8:45 and 11:15? In the figure below, a student might count the full hours from 10:45 all the way till 3:45 and then subtract 15. Or you can count by 15 minutes to 11 and then count by 4 hours. Students must understand 5 cents, 10 cents, and 25 cents. A dime can buy the same thing as 10 pennies can buy. Naming the total of a group of coins is the same as mentally adding their values. Students often sort their coins and start counting from the highest value. They're capable of combinations between putting a 5 and a quarter together make 30, and coins are fortunately multiples of 5 and 10. A good activity would be 1837, money skipping count.